All right, guys. So today we are going to continue yesterday's lesson. Yesterday we left off on lesson 4-2, example 1. All right, so here we are. Example 1. Again, you're on page 184 in your workbook, and example 1 tells us to rewrite a rational function to identify asymptotes. So who remembers what an asymptote is and can tell me the definition?
Oh,
Annie?
basically a line. Oh, sorry. It's a line on a graph. I don't know.
Ellie?
I just messed up.
You want to help him out, Ellie?
There is a line on a graph that guides the end behavior of the function.
Correct. An asymptote is a line on our graph that guides the end behaviors of our graph. And our lines, the graphs approach this line but never touch them, right? It is the undefined part of the function. All right. So in this example, I want to show you guys a couple of things first. So this tells us to rewrite the function g of x using long division. And then how is the quotient related to the reciprocal function? F of x is equal to 1 over x. So it's asking us what the transformations are. Who remembers long division? Okay, great. So my last few classes have had a very hard time grasping this concept during long division with these types of functions. So to kind of get us ready for that, you guys are gonna think this is maybe a little dumb, but I'm gonna give you guys a very, very simple example so that you can understand the reasoning behind what we're gonna do in long division and then apply it into this function. So before we divide 4x by x minus 3, I want to do something very simple. You guys all know what 7 divided by 2 is, right? What's 7 divided by 2? 3.5. How is that as a mixed number? 3.5, right? 3 and then 1 over 2, right? Simple enough, right? So 3 and 1 over 2, right? So I'm gonna divide 7 by 2 using long division. This is how you would set it up, right? 7 divided by 2, and then you would set it up like this: 2, and then the long division operator, and 7. So the goal of long division is we want to eliminate everything inside of the division operator by subtracting, right? And we're going to subtract the product of 2, which is what we're dividing by, and the numbers that we write on top. So how many times does 2 go into 7 evenly? 3, right? So I'm going to do 3 times 2, and that's what I'm subtracting from 7, right? 2 times 3 is 6, right? So I'm going to subtract 6. And what is 7 minus 6? 1, right? I know you guys are used to normally, you would add a decimal and put 0 and then a decimal here, drop this down, 2 goes into 10 5 times, and then you get your answer 3.5, right? That's the way that you guys are used to doing it. We're going to do it a little bit more simple. So here we are. We just identified that 2 goes into 7 3 times evenly. We subtract 6 from 7 and we get 1, right? This is what we call a remainder. The 1 is a remainder. So what we're going to do is we're going to put our remainder over the number that we're dividing by. So that means that we would put 1 over 2. A remainder. So we're putting this remainder right here over this number that we're dividing by, 3.5, which is the same thing that we're doing, right? So we're gonna apply that same concept to when we're doing 4x being divided by x minus 3. We're gonna be left with the remainder, and what we're gonna do with the remainder, we're gonna put it over what we're dividing by. All right, so let's clear that. So before I show you guys the solution, I want us to do it together so I can walk you guys through it. So we have 4x being divided by x minus 3. We're going to set it up in long division. X minus 3 is divided by, or 4x is being divided by 4x, x minus 3. So how many times, and what you're doing when you're doing long division like this, you want to identify how many times this first term goes into this term. So how many times does x go into 4x evenly? 4 times, right? So on top, I'm going to write 4. And then you're going to do the product of the number on top by what you're dividing by, and that's what you're subtracting, right? So what am I going to be subtracting? 4x minus 12. That's what I'm subtracting, right? I'm going to put plus 0 here just so I can visualize the subtraction there. All right. So what is 4x minus 4x? Cancels out, right? 0. And then what is 0 minus? So we're going to read this as 0 minus negative 12. It's positive 12, right? If you're subtracting a negative number, it's the same as adding it. 0 minus negative 12 is positive 12. So what is this 12 right here? Remainder, right? So what am I going to do with my remainder? Exactly. I'm going to put it over x minus 3. So then my function is 4 plus 12 over x minus 3. 4 it was 4 plus 12 over x minus 3, right? And I know you guys are used to seeing, so this is h and this is k, right? I know you guys are used to seeing k at the end, so you can rewrite this so that it is in the form that we're used to seeing. So 12x minus 3 plus 4. These are the same functions, right? You can move things around, but this is what we're used to seeing right here, right? The 12 over x minus 3 plus 4. So now that we have our function, let's talk about the range, the domain, and our asymptotes. Can anybody tell me what my domain for this function is? Sydney? Okay, no problem. Can anybody tell me what the domain is? And you can actually tell the domain and the range from this function that we have here right now and from the original function as well. Okay, so 3, yeah, x does not equal 3, right? X does not equal 3. That is my domain. Does everyone understand why? Okay, so I didn't see a lot of yeses, so I'll explain. So domain refers to what x values can be plugged into this function. So there are no restrictions to the domain except for one. The one restriction in this function is going to be the number or the value for x that is going to give us a denominator of 0. So our denominator is x minus 3. What number would give us a denominator of 0? 3, right? If you do 3 minus 3, you get 0. And then you have a 0 as a denominator, which you cannot do. That would be an undefined expression, right? You can't divide any number by 0. So for that reason, our domain is all real numbers except for 3. That's the only number that we cannot plug into this function. And you could do it from the original function as well, right? 3 minus 3 is 0, right? So you can look at either one of these functions and identify what the domain is. What about my range? No? Sydney? So it wouldn't be 0. This may be easier to, the range is a little trickier than the domain. The range is really, the simplest way to get the range is by graphing it and then looking at where there is a hole in your graph on the y-axis. But there's a way that you can do it as well from the functions, but it's not quite as clear. It does take a little bit of thinking, getting your range from the functions, but I'm going to show you guys the two easiest ways to do this. So if we wanted to get our range from this original function, 4x minus 3, what you would do is you would do your leading coefficient in your numerator divided by your leading coefficient in your denominator. So what's my leading coefficient in my numerator? 4. And what's my leading coefficient in my denominator? 1, right? So what's 4 divided by 1? 4, right? So your range is y does not equal 4. So if you're in this original function, you would do leading coefficient on your numerator divided by leading coefficient on your denominator. And then if you want to find your range from this function that we arrived to by using long division, you would just look at the value for k. And I'm going to explain to you guys why that is in just a second when we look at the graph of it. But if you have this function right here, you would look at k, and that tells you what your range does not equal. So my k here is 4, so my range is y does not equal 4, right? Does everyone understand? So you can get the range and the domain from either function. And then let's talk about the asymptotes. Can anybody tell me what my asymptotes are based off of the information we have so far? 3 and 4, right? Which one's which? Which one is my horizontal? That is going to be the value for y. Huh? Y, right? My asymptote, I actually don't know how to spell it. My asymptote is y equals 4, right? What about my my vertical asymptote? So vertical asymptote would be your x equals what? X equals 3, right? So what your domain cannot be is what your asymptote is going to be, right? Because the domain x does not equal 3 means that there's going to be a hole in the domain at x equals 3. And that hole is what's going to guide your end behaviors, right? Your graph can never touch where x is 3, right? Because x does not equal 3. So your graph can never touch that, and it's going to guide your end behaviors. Your line is going to approach it, but never touch it. And then the same with your horizontal asymptote. Y does not equal 4, meaning that is a hole in the y-axis at y equals 4. So that means that your graph is going to approach y equals 4, but it's never going to touch it. It's going to guide the end behaviors, right? All right, so I'm going to clear that. And then I'm going to show you guys the solution. And I'm going to show you guys, because the textbook does not tell you how to find the range in the domain. They kind of just figure you're supposed to know. That's why I wanted to explain that to you guys before, because the textbook is going to make it a little bit confusing. But that's why I want to show you guys beforehand so that you don't get confused once we go in here. But in this function right here, what are my transformations? Jack?
Shift up to the y-axis by 4 and shift to the right of the y-axis by 3.
Yep. Does everyone agree? So this indicates a shift up by 4 and a shift to the right by 3, right? This is H and this is K. So when your graph shifts to the right 3 and then up 4, what else is shifting right 3 and up 4? From the parent function. Your asymptotes. So if in the parent function f of x is equal to 1 over x, your asymptotes are y equals 0 and x equals 0, right? So if you have a transformation and you're shifting to the right shifting to the right 3, your asymptote is also going to shift to the right 3. So if your vertical asymptote was y, or sorry, x equals 0, and then it shifts 3 units to the right, what is your new asymptote? So it was x equals 0 and it shifted to the right 3. What is the new asymptote? X equals 3, right? And then if you had a horizontal asymptote from the parent function at y equals 0 and it shifted up 4, what is your new asymptote? Y equals 4, right? So these are transformations right here, and that's why they tell you, they also indicate what your asymptotes are and what your range and domain are, right? This right here represents a hole in our domain because our function can never be at 3 on the x-axis, right? So that's going to be an asymptote. And then our graph can never touch y equals 4 on the y-axis, right? All right. So let's move on to the next example. You guys are going to do this one on your own. Oh, sorry, I forgot one thing in the previous example. What does this 12 do to our graph? Because the parent function is 1 over x, right? Now that 1 changed to 12. Juan, did you know? It is a vertical stretch. Perfect. So this number right here represents a vertical stretch on our from our parent function. So I have this graphing calculator pulled up because I want to show you guys that vertical stretch. So here's the parent function, right? 1 over x. I'm going to zoom in a little bit. So this number tells you what your y value is when x equals 1, right? So when x equals 1 in the parent function, y is what? 1. So this number tells you what your y value is when x equals 1. So if x is 1, what is my y value? 1, right? And then you can see that on the graph. When x is 1, y is 1, right here, right? So if I change this to 12, what's my y value when x is 1? 12, right? So it is a vertical stretch. Every point on the graph stretches by 12 units. So before from the parent function, I was at, when x is 1, y equals 1, right? So now this stretched it up 12 units, right? So now when x is 1, y is 12, right? So every point, so this point would stretch up 12 units, right? So that's what that does. And then we're going to add the other transformations. So then we had x minus 3. What is that going to do? The minus 3? Shift to the right. Okay, so our graph shifted to the right. And then we had plus 4. What is the k of plus 4 going to do? Up 4, right? So you guys understand the vertical stretches now? And then the translations? All right, great. So now you can do the next one on your own. What? Okay, so in this function here, to graph it very simply, you guys would have to change it to the other format that we had by using long division. So you would divide 6 by 2x plus 1. But can you guys tell me what my domain is here? 1? Negative half. Does everyone agree that the domain is x does not equal negative 1/2? How did we get that? Exactly. Negative 1/2 is the number that would give us excuse me, a denominator of 0. Juan, you said 3. That is the range. So I think you were thinking about the range and not the domain. Oh, where's my pen? So the easiest way to find what your domain is to, where's my pen? The easiest way to find your domain is you set your denominator equal to 0. So my denominator is 2x plus 1. So I'm going to set 2x plus 1 equal to 0 and figure out what my 2x plus 1 is equal to 0. So to solve for x, I would subtract 1 from both sides. Then I get 2x is equal to -1. Divide both sides by 2. And you get x is equal to -1/2. And then you go back to the function. What is 2 times -1/2? -1. And then -1 plus 1? 0. So the easiest way to find your domain is set your denominator equal to 0 and solve for x. And then, so we got x is equal to -1/2. So that is what x cannot equal. So I'm just going to write a dash like that. My domain is x does not equal -1/2. So here's the easiest one. What is my range? Y does not equal 3. How'd you get that, Ani? 6 divided by 2, right? My leading coefficient in my numerator divided by my leading coefficient in my denominator. 6 divided by 2 is 3. So y does not equal 3.
No entiendo mucho.
¿Qué no entiendes? ¿Pero qué es eso? ¿Qué de eso no entiendes?
Como encontrar el domain, el range.
Ok. El domain es los números que no puedes plug in for x. Ok, so el domain es los números que no puedes reemplazar con x. Right? That's right. Okay. So, entonces tienes que averiguar cuál número haría el domain equal 0. La manera más fácil es set the domain equal to 0. So we have 2x plus 1 is equal to 0, right? Ahora solve for x. Soluciona por x. -0.5, right? So the domain, entonces you got that x is equal to -1/2, ¿verdad? Or 0.5. Entonces the domain cannot equal that, and that's it. The domain does not equal 1/2. Porque ahora plug in 1/2 into x. So what's 2 times -1/2? Do it on your calculator. Do 2 times -0.5. 0.5.
Oh.
Negative what?
1.
-1, okay. Oh, they said -4, sorry. It sounds like 4, right? So, okay, so it's -1. So what's -1 plus 1? 0. Ahora in your calculator, do 6 divided by 0. What does it tell you? Huh? Error. You can't do that. You can't divide a number by 0. So your domain is going to be every number except for the number that's going to make this equal to 0. So el domain es todos los números, pero no.
And then you solve for x.
You solve for x, and then that's what x does not equal.
Oh. And that's your answer.
And that's your answer for the domain. The range, you do the leading coefficient en el numerator. Leading coefficient es el número que está enfrente de x, o enfrente el terma más alto o grande. El terma,
Término.
el término más alto,
Grande.
más grande, whichever, right? So if you had x squared plus x squared is the highest term, right? But here we have x is the highest term, ¿verdad? Entonces el leading coefficient va a ser el número enfrente del terma máximo, término máximo, y dividido por el terma en el denominator máximo. Okay, so ¿qué es 6 divided by 2? So that your range is y does not equal 3. Simple, right?
Yeah.
All right, so did you guys figure out the domain and the range? Oh wait, we already talked about that. Sorry, did you guys figure out the asymptotes? What are the asymptotes? Yeah, x equals -1/2 and y equals 3, right? What is the new function when you do synthetic division? 3 over 2x plus, it's not plus 1 though. Oh wait, sorry, 2x plus 1 and then what? Sorry, yeah, you're right, 2x plus 1 and then what? So 3 over 2x plus 1 and then what? What was your remainder? Oh wait, your remainder was 3. What was the number you put on top? 3, right? So plus 3. All right, so now, did everyone get this as a new function after you did long division? All right, so let's, yeah. -3 on top. Oh, so you're going to be subtracting, right? So you don't want to subtract -3. You want to subtract +3, right? From 3. Here, I'm gonna show you guys. I'm gonna do it here. Give me 1 second so I can get a little blank space. Okay. All right. So I'm dividing 6x by 2x plus 1. No, I'm subtracting, right? So what number? How many times does 2x go into 6x evenly? 3, right? Because I'm subtracting, so I want it to be positive, right? Because I want +6 minus +6, right? So what's 3 times 2? 6x. And then what's 3 times 1? Plus 3. There's nothing here. I'm going to put a +0 just to help me through the through working this out. What's 6x minus 6x? 0. And then what is 0 minus 3? -3, right? So what is this right here? What's that called? The remainder, right? So minus 3 over 2x plus 1. Yeah, so I know what you're thinking. We're subtracting in the when we're doing long division, we're subtracting. So it's already gonna, like, you want the numbers to have the same sign in front of them because you're gonna be subtracting. So you wouldn't do -3 because then that would be 6x minus -6x, which would actually give us 12. All right, so now we have the function -3 over 2x plus 1 plus 3, right? So now I want you guys to pay attention here because I don't want you guys to get confused on the translations. What is my vertical translation? That one's easy. My vertical, so up and down. I'm going to go up 3, right? What about my horizontal translation? Please don't say 1 to the left. It's not 1 to the left. What is it? Half to the left. Does everyone understand why it's half to the left? Okay, so here is the denominator, right? Here, let me write it more clear. It's a little. So this right here, the 1 is h, right? H tells us if it moves left or right, but it's not h yet because in the original function, right? It's f of x is equal to 1 over x minus h plus k, right? So k is good, but if you look at the difference, there's a 1 in front of this x right here, right? But over here, there's a 2 in front of x. So you have to factor out that 2x in order for you to get the actual translation. So how do I factor out the 2x? I'm going to divide them by 2x, right? So now I have -3 over, I'm factoring out the 2, and in parentheses, what is 2x divided by 2? X. And then what is 1 divided by 2? Plus 1/2, right? So now this is h. Does everyone see that? So our translation is actually moving to the left by half a unit, not by 1 unit. Does everyone understand? Does everyone understand that? Okay, good. I just want to make sure because my last class was very confused on that. But you have to make x be by itself, right? In order for you to get the true transformation. And then plus 3. All right, so now this function. So we know what the domain, the range, the asymptotes are, right? So now let's graph this with the transformations. So what's going to happen with this graph? What is this transformation going to do right here? Reflecting, yes, across what? Yeah, exactly. So Ellie said this negative is going to reflect across the x-axis, right? Everyone agrees? What is this going to do right here? Or actually, let's look at the 3 on the numerator. What is the 3 going to do? A vertical stretch by 3, right? What is this half going to do? To the left by half a unit. And then what is this 3 going to do? Up 3 units. So our total translations are reflection of over the x-axis first. Then it's going to be a vertical stretch by 3. Then it's going to get translated to the left by half a unit. And then shift up 3 units, right? So I'm going to show you guys on the graphing calculator here. So the parent function is 1 over x, right? Oh, let me clear that. So this is the parent function, 1 over x, right? What was the first thing? The negative, right? Reflects across the x-axis. What's next was, this was a 3, right? So it's a shift, a vertical stretch by 3 units, not a shift, sorry. Next was, we have 2x minus 1. And that is a shift to the left by half a unit. And then we have plus 3, a shift up 3 units. Does everyone see those transformations? All right, great. All right, this is the last one we're going to do for today. So I want you guys to do this on your own. This one's going to be a little less complicated than the last one. I'm going to come around and help you guys if you need. Michael? So those are the range and the domain. What about that? Oh, that's yeah, exactly. And then you would just graph it. So I want you to try it. So the parent, what would happen with the parent? If you can just describe what the transformations are, you don't have to graph it. So what would be the transformation?
Por eso cuando escuché esto le dije, no, marica, quería. O sea, lo único diferente fue que vi ahí dice está hablando en español.
Yeah, a vertical stretch.
Yeah. Y le encanta este gusta mucho porque tiene demasiado autismo. Me da vuelta esta vez.
You guys doing that?
Pero otra cosa no le da un dolor. Yo ya la vi que. No, para guardar la equilibrio.
Yeah, so it would be, 6 divided by 1. It's the coefficient.
Yeah.
Oh, wait, it's actually.
Yo necesito usar lente, lo que pasa es que no me gusta usar.
When you do that, that's based off the original function. So it would be 1 divided by 1. Here, you already have a 1 outside. Remember, this is k. So k tells you the range. If you go to this version, if you have this version, you would just do the leading coefficient. So 1 divided by 1, which is.
Bueno, yo ni nada de
Yeah, so x does not equal 6 is the domain, and then that means that asymptote equals negative. first part.
So, see, right, not to stress the, translation that goes over.
Yeah, so
Vertical,
So to do that, you have to change this function by dividing x by x times 6, which. So you have to divide it first, and then that will give you all the translation. Yes. Correct. So that means that you're asking for what you give, and it goes to the asking for x plus equals. So that's out of your range, you can get it from this function. You do the leading coefficient divided by the mean coefficient. What's leading coefficient? What's leading coefficient? What's 1 divided by 1? 1 is not equal 1. Yeah, that is your horizontal asymptote. Y equals. Ahora tienes que hacer synthetic division para hacer or not synthetic division, pero long division. And that's just do x is divided by x. So how many times is x plus x?
Gracias. Oh my God. ¿Sabes yo cuánto quiero 5,000 veces? 4. O sea, pero si quieras después, ¿cómo se llama?
No. Después de la-
No. Bien.
So you subtract this. So what is x minus x?
Bien,
X minus x.
Yo,
What is 0 minus negative. So that's your range. So your range is 6.
no, era más que ¿verdad? Era casi igual que no está ligado.
por eso.
No, me gusta ese más que
So this is
donde está tratada de otras raitas que están diferentes, que no ellos casi igual.
This is the same as having a plus
Pero
one.
sí, como decían, porque como unieron la papa frita y el arroz juntos, y después pusieron antanita, guisada, salchicha, salchicha frita, y pollo, carne de vaca,
So with the
frita,
you want to go off the parent.
una carne china y que es frita.
So you have 6 over x minus 6 plus 1. So the parent has to be.
Oh my God.
Por eso tenemos que enseñar las palabras que ustedes mandan.
If you want to do it very simply, you can just put it together. Oh, is that the same function? So put the function in calculator.
¿Cómo es digo con
So do 6 and then divide by and then write in parentheses. X minus 6. The parentheses are close.
Yo no hablo con la E, ni la E.
Sí, no sé qué son las palabras, ya ni me acuerdo cuál es.
Tenía L y F.
And then the other parentheses you go.
En el punto inicial cambiamos toda L por
And then
F.
you put the bracket.
Bueno, de la parte que yo estoy.
So that's what
Tú
you
no
write.
lo haces, pero otra gente manda la atención y esto.
No.
Poner la I, donde va. No, no, es un
If
campesino.
you put second and graph, it'll give you the values on the table. Right, so when x is 0, y is 0. So you can draw a little, x and y axis and have it plug in.
This is what.
Yeah, that's correct. So you have the correct function. And then the range y does not equal 1. So
We never did it.
X does not equal 6. Correct. Asymptotes are x equals 6 and y equals 1. Right? And then to graph it, you're going to want to put in a graph calculator.
You got it, right? I got it.
So you're going to go to y equals. Oh, you got it? All right. So, okay. So you're supposed to put, you're supposed to put parentheses around. So 6 divided by x minus 6.
Oh my God.
Yeah.
Put 7 it gives you the points. So you can graph it. So like when x is 0, y is 0. There's a point right there. At 0, 0, there's a point. And you just draw your x and y.
Oh my God.
All right, Kazi, I'm ending the Zoom meeting.